Okay, this is the solution to the 2000 question I gave you from the AP Calculus exam, question number 2. The question about the runners running on a straight racetrack, and here's the picture. Okay, question A says find the velocity of runner A. So let's start with that one. This graph is the graph for the velocity of runner A. And I want the velocity at time 2. So all I have to do is look at time 2 and figure out, where I am on the graph. The only thing is it doesn't look like I can tell exactly what point that is. But you know what? I know an ordered pair, 310, and I know an ordered pair is 0, 0, and that's a straight line, which means for part A, I can come up with the equation of that straight line. Okay, how do I find the equation of a line? Well, I just need a point. I have 2 of them to choose from. I think I'll choose 0, 0, and I need a slope. Well, to find the slope between 2 points, I just do y2 minus y1 over x2 minus x1. So if I do that, I get 10 minus 0 over 3 minus 0, or 10 thirds. That means the equation of the line is y minus 0 equals 10 thirds times x minus 0, or in other words, just y equals 10 thirds x. I now want to know what is the y value when x is 2. So what's the y value when x is 2? It's 10 thirds times 2, or 20 thirds. It does also say to indicate units. The units are given right there. It's in meters per second. So the answer for runner A is 20 thirds meters per second. For runner B, I'm given an equation for the velocity for runner B. So all I have to do is plug in 2 seconds into the equation for runner B. So that would be 24 times 2, which is 48. And then the denominator, 2 times 2 is 4, plus 3 is 7. So 48 sevenths, again, meters per second. That's part A. Now part B, find the acceleration of runner A. Well, what we know about motion is that the acceleration is the derivative of velocity. So first for runner A, well, the derivative on the velocity graph means the slope. And at time 2, I already figured out. The slope right there is 10 thirds. So that means the acceleration for runner A at time 2 must be 10 thirds. The units on that would be meters per second squared. Okay, for runner B, I need to find the derivative of the velocity equation. To find the derivative of this velocity equation, I'm going to have to use the quotient rule. You might want to pause this video and do the quotient rule on your own to make sure you can do it. All right, here I go. The denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. If I simplify that, I think that's 48t plus, I believe, 72 minus 48t, hopefully I did the arithmetic right, over 2t plus 3 squared. So I think I just get 72 over 2t plus 3 quantity squared. Now I was asked to find the acceleration at time 2. So I'm now going to plug in time 2 to figure out that acceleration. 2 times 2 is 4, plus 3 is 7. 7 squared is 49. So I get 72 over 49, and the units again are meters per second squared. Okay, that's question 2 from the year 2000 AP Calculus exam.